During this experience, we are going to gain competencies through comics in the object-oriented programming on S/4HANA ABAP within the framework of Scrum-Agile according to ITIL, the 7 guiding principles. We are going to gain competencies in how to develop object-oriented ABAP code and to develop dynamic object-oriented ABAP code. Moreover, how to implement a body using TVARVC parameter table. Furthermore, how to build LSMW program to upload the parameters to the TVARVC table. We are going to learn while enjoying, not enjoying while learning. Competences through comics. Hasta la vista, ABAP. Technology Blue Pages. To start this experience, you have to have a bit of experience in ABAP, at least basic knowledge. The competences which we are going to build during this experience are located within the intersection among ABAP object-oriented programming, Agile methodology, Scrum approach, and the 7 guiding principles of ITIL. Exactly within this intersection. Let's start with an introduction about the Agile. What the Agile methodology is. Simply, it is a project management methodology that organizes the activities and the phases we need to go through to convert a requirement into a deliverable. As you see, we start with the planning phase where we will have the requirements and according to the priorities of these needs, we can organize our work, which should go first, which should receive our utmost attention and focus. The second phase, as we see, is the design. So we need now to analyze the requirement, to build a solution design to fulfill these requirements. And then the development phase. So we turn the solution design into tangible software, into a program or configuration. And then we test what we have developed and we let the business test it as well. So this is code testing phase, whether that is unit testing, piece of development, or system integration and or the UAT, the user acceptance test. Once tested successfully, we can move to the next phase, which is the release. So we release the development to the production system. We receive feedback. The development, which is now live, will be validated and evaluated by the business within the live environment. According to the feedback, we can initiate another iteration of this cycle. And then we go over and over and over till the product becomes more mature and improved. So this is the cycle of Agile. What a sprint is? Sprint is the period of time that we spend to execute these phases, to go through these phases, starting from design to release or plan to feedback. So this is a sprint. The ideal situation and the best practice is to have 2 weeks sprint to guarantee that we are dividing our work, slicing it into a controllable, manageable small pieces that we can deliver successfully. Over a sprint, we go through this cycle. Let's see what are the most famous meetings during this cycle. Definitely, we start the entire period, which is a 1 year, or which is 1 year or a half of a year, by a plan, a comprehensive plan of what we are going to do, what are the projects or what are the requirements that we need to fulfill during this long-term period of time. We start it with an event or a meeting which is called PI planning, product increment planning. In our case, SAP is a product, and we increment this product, adding more and more functionalities to fulfill the increasing or the incrementing requirements. So during this meeting with business solution architects, specialists, business experts, business key users, product owners, developers, and all of the main stakeholders of the business, it is discussed and decided what will be the major project that we are going to work on. These projects, or the outcome of this PI planning meeting or event, will be features. Each feature is a major project that we are going to work on. Then the feature will be divided or subdivided into user stories. For example, we are going to improve the procurement process. It's a feature. So the feature is the improvement of procurement process or sales process. What will be the user stories? We need to automate the creation of the purchase order or the sales order in the sales and distribution process. So these are user stories. But to fulfill this user story and deliver it, we need to investigate what would be the optimal solution, the best practice. There, we should use a custom development or a standard solution or a hybrid solution of standard and custom development. So we can investigate through a spike. So we raise a spike or we create a spike to investigate these solution, the requirements and solution of the user story, to get more clarity over the requirements or to investigate the solution. And then we can start working on the user story in form of tasks. So we create tasks with reference to the user story. For example, having a demo on what we have on the system to get the delta, and then development, a task for development, a task for testing, a task for performing the cutover activities, and so on. When we have user stories created, we need to prioritize the user stories, spikes, tasks, what should be performed first, what should be receiving the utmost attention according to the priority, according to the urgency and impact. So during the sprint planning meeting, the product owner, specialists, developers, the Scrum Master discuss the priorities and assign the user stories, spikes, tasks to each member of the team. Then on the daily stand-up meeting, the team will start sharing the status of each user story, tasks, spikes, what is the progress, what is done, what will be done, and what are the impediments, if there are ones, and so on. As we said, we can have a demo meeting with the product owner or business key users. Backlog refinement. So when we have the tasks, user stories, and spikes. We put them in a backlog in a queue. We can reshuffle this queue according to a change in the priority or a change in the business requirements. For example, a requirement became more unclear and we need to put it back in the backlog till it becomes clear it's possible. So during the backlog refinement meeting, we can reshuffle the queue or the backlog, resetting new priorities to the user stories, spikes, and tasks. Technical planning and demo. So if we need to have a technical discussion, we can have it during this technical meeting. And at the end of the sprint, we have retrospective planning meeting. We discuss what went well, what didn't go so well, what needs to be improved, what is achieved from the sprint goal that we discussed during the sprint planning. So we celebrate our success during the retrospective planning and discuss how to improve in the future. So in the Agile, we perform these activities through these phases using these tools over these meetings. PI planning in the beginning of the entire period, which is 1 year or 6 months period. But in the beginning of the sprint, we will have sprint planning and we end with retrospective planning. I hope this is clear. We perform these phases using these tools over these meetings and this period of time, which is 2 weeks according to the best practice, expressed for 3 weeks or 1 month for the support stream, or in some business organizations. It's also possible. There are some principles that we need to follow in order to achieve a success in creating a value to the business. So when we work on a requirement, when we work on a deliverable, we need to focus on value. How this deliverable be saving time, effort, cost for the organization. We need to start where we are. We need to start with what in our hands. For example, we are going to automate the creation of the purchase order through an uploader. So the value is that we are going to save the creation time. At the same time, we start with what we have. We have, for example, a standard baby or a standard function module that we're going to use in SAP or reuse in our program. Or we have an existing program or existing recording or existing XYZ that we're going to reuse and build upon it a solution. So we start always with what we have on hand. Then we progress iteratively with the feedback. Always we involve the stakeholders as early as possible and as much as possible. We show them what we have, what we are going to do. We receive feedbacks, and according to these feedbacks, we modify our moves, our paces towards what is required. So this is how we progress iteratively. So we need to be open for changes. We don't need to stick to what we think the way to finish early. We need to create a value. So we need to progress iteratively with feedback. Collaboration and promotion of visibility. So we need to involve as many stakeholders as much as possible. Collaborate with all of them. Having what we are working on as visible as possible for the stakeholders. Then thinking and working holistically. Definitely we need to think in the existing solution, the current processes, what is the impact of what we are developing comprehensively on the current situation. What is the impact? That's why we perform or we do an impact analysis. Then we keep things simple and practical. There are two dimensions: the development and the usage. In the development, we need to be sure that our development, the code is simple, reusable, and practical. That's why we're using object-oriented programming. Make things easy, don't overcomplicate things. Solve things with the easiest way, not the most complicated way. So that's why we think always in writing less code to solve issues, and writing a code which is reusable. So we keep it simple. At the same time, the usage of our program shouldn't be complicated. We should create a program that will need the least number of clicks and pages. Simplify and make it practical. Optimize and automate. Always think about automation. Optimization, how to optimize the process, how to optimize the creation of the purchase order, the creation of the sales order, how to automate them, make them simple, make them faster. So if we follow these 7 guiding principles, we can achieve a success. We can achieve successful. We can achieve successfully the goal of building and creating a value to the organization. Let's now discuss the object-oriented programming. Just let's start with the procedural programming. What you write now in a code in a sequential way, you put everything you want to achieve sequentially. This is procedural programming. As long as you are not writing objects or classes, then it's procedural. You put all of the instructions, all of the in a sequential code. This is similar to writing or leaving a sticky note, writing I will travel to New York. Then I would like to write another sticky note, I will travel to California. In procedural programming, the only way is to write it. I will travel to California. I will travel to XYZ. If I would like to write different destination, I will have to write I will travel to whatever. So I'm exerting more effort, spending more time, having redundant words and sentences to achieve what I need to achieve. In object-oriented, it is different. This approach organizes the code in a way, code makes the code more efficient and reusable. So the object-oriented, for example, if I'm writing the class, then I'll put into it, I will travel to. Then I create objects with reference to this class that which will use or reuse the content of the class, which can be variables, can be functions, can be methods, can be whatever, commands. And then I pass the destination to the object, New York, and I will get the new sentence as you see. Same as here. I'm creating an object with a reference to the class, passing the destination and receiving the entire statement. Less effort, less time, more efficient, and I'm reusing the code. So in object-oriented, I have classes, objects, which enables me from making my code more efficient, avoiding the redundancy, saving more effort and time. In object-oriented programming, there are Some concepts facilitate the efficiency and the reusability, like inheritance. Now I have a class, as we discussed before. This class contains a statement, I will travel to. It is printing this. If I would like to create another class, which will be I will enjoy, then I inherit from the first class to the second class. As you see, I will, then I override travel to by enjoy. So it will be I will enjoy another class. This is inheritance. I inherited from the first class to the second class the words, variables, functions, methods, commands. And then I create an object with reference to the class, passing the value receiving or the input receiving the output. Here, the destination is an input. The output will be I will travel to New York. Same here in the new class, Amsterdam. I will enjoy Amsterdam. This is inheritance. Similarly, the multiple inheritance will work following the same logic. Two or more classes to one class. I will travel to. I will enjoy. I can inherit from these two classes to a new class which contains I will travel to and I will enjoy. And then I create an object with reference to this class, passing the destinations, New York and Amsterdam, to have the two sentences within this object. I will travel to, I will enjoy as two sentences out of this. This is multiple inheritance. I'm inheriting to a class from several classes. The concept of abstraction. Simply, I can create a class which functions as a template. I'm not going to create an object with reference to it. It's not allowed. But I will inherit two classes from it, like I will. The class which contains I will is an abstract class that we are going to inherit from it to class A and class B. I'm inheriting I will. Then I'm adding these additions like travel to or enjoy to it. By turn creating the object with reference to the class, passing the input, receiving the output, which is the new sentence. This is abstraction. Encapsulation. Encapsulation. This concept refers to the possibility of hiding part of the class, which can be variable, function, method, some commands, not to be inherited to the child class from the parent. So in the class, I can define variable or method as private, public, or protected. So if it's private or protected, when I'm trying to inherit, as you see here, I'm inheriting only I will, because I will was public, not private or protected. But travel to was private or protected. That's why it wasn't inherited in the new class. Otherwise, it would have been I will travel to enjoy, which is wrong. So I will was public, travel to was private or protected. So this is the concept of encapsulation. The method. The class is subdivided into methods or functions. Each method will have an interface that I pass the input to get or to receive the output. As you see here, I have in this class method A and method B, or method 1, method 2. The interface is a country or a town. Here it's quantity. So I pass to this method New York, then it will be I will travel to New York. I pass to the second method the quantity of the tickets or the number of tickets, 2 or 3. It will be I will buy 2 or 3 tickets. So the method is subdivision of a class, which enables me from calling a specific piece of code within the class through the object which is created with reference to this class. Polymorphism. Polymorphism is a concept which has two types: runtime and compilation. For example, I have class A and class B. The methods here, method which receives the country or the town on its interface, as you see, and in class B, the same method name which receives town or country, but we can differentiate, or the system will differentiate between the two methods via the class. So this is class A, this is class B, but the method name is the same. So this is called runtime polymorphism. Compilation class has two methods. One has the interface as country or town. The second has interface as quantity. Both of the methods are having the same name, method, but the system will differ, or the compiler will differ, but the compiler will differentiate between the two methods via the type of the data which you are passing to. So if I'm passing a town, system will look, oh, this is a quantity, but this is a town, so this method is meant here quantity, then this method is meant, and this will be called, and we're going to execute this content, not that content. So this is polymorphism, identifying which method either through the class name or the interface data. I hope this is clear up till the moment. It will be more clear when we'll be discussing the course into details in a practical way. As we discussed in the beginning, the course is an intersection among ABAP object-oriented, agile methodology Scrum approach, and the ITIL 7 guiding principles. So now we're going to discuss practically how to write ABAP object-oriented code to fulfill or to be aligned with ITIL 7, the 7 guiding principles, and within the framework of Agile Scrum. Now let's summarize. The class is a container, template, or a blueprint which contains functions, variables, the pieces of codes, methods, and so on. The abstraction, the abstraction is using the class only as a template, but no objects can be created with reference to it. Object is the functioning instance of the class. Inheritance is adopting the components of the class to a subclass. Multiple inheritance is adopting the components of more than one superclass to subclass. Encapsulation, the component of the class, are not accessible by objects and other classes unless it is permitted. Polymorphism, runtime is using the same method name in different classes. Let's start now with the practical part of our experience. ABAP object-oriented. So we are going now to show how to implement the OOP object-oriented concepts in SAP S/4HANA ABAP. Class. Now we are going to build a class to check if the parameter in the TVARVC table or the parameters table is available or not. And we are going to start with the transaction SE24, the class builder. So we type here the class name, and then we click on create. Then here we type the description. We select it as public. We're going to discuss the other specifiers later. Be sure that the final checkbox is unticked, not ticked, it's empty, and then click on save. Here you select the package and save, then transport request, and you save. Now the class is created. Let's build the content. Here we define in the methods tab the methods. Each method is a container of the code or piece of code. So when we call the object later, or when we call this class later, we will call it, we will call the piece of code within the method using the method name. So here we type the method name, we select it as an instance method, then public. Then we assign the attributes. These are the data or the variables which you are passing to or retrieving from the class. Here, instance, we select an instance attribute. Instance means that we can send and receive data from it. Static means it's defined as a specific value, and this value will be static, will not be changeable. An instance means a changeable data or a changeable value of the attribute or the data. Then we select all of them as public to be here accessible by all of the other classes which might inherit or the objects. We can define, for example, the data which will not be accessed or which we do not need them to be accessible by other classes as protected. Then here we assign the type, whether it is string, integer, or similar to others, another structure or existing table field. So we'll type it here in associated type. To write the code and the source code, we can select it from the menu bar, source code based. Then the system is going to display the code of the class, which we can use to, this is a class code shell, which we can use to add to the code. As we see, after using SE24 to define the class, the code, the definitions were transmitted into code or converted into code. Here, public section, the data which we defined, the class definition is public, and then data, the method which we defined is here in the code as well. This is a protected section and private section, nothing yet. We there just accept variable type which we selected as protected. The objective now is to know how to create class, how to create or implement the concepts of object-oriented programming in ABAP. Then we will come later to the contents, and we are going to articulate them through the big real example, the practical example. Here you see the method is created as well. Then Control S to save, we click on activate. So now the class is created. The object, how we call the class with its own contents in our code. As an example, we are writing the code within the body me process po cast. So here in this shell, we are going to call the class, but we call it through create an instance of it, which is object. So now we define the object, type reference to the class which we defined. Then we create object here, which is z cell tv. Then we pass the values of the input data to the class. So the name, it's one of the variables which we defined earlier. And this name is the TVRVC parameter name. And then the low TVRVC table has two main columns, low and high. Here we are passing the low is the document type of the PO. Then we call the class method, calling method of the class, method which we defined out of this object. And this object was created with reference to the class, as we have seen earlier. Then we receive the output will come here. If flag equal 1, then the code continues. So what we have done, we defined the object as a reference to the class, and then created the object in this line, and then we passed the inputs to the object, receiving, and then we called the method. Finally, we receive the output. So this is how to call an object or to create an object with reference to the class. Moving now to the inheritance. Now we know how to create a class, how to create an object with reference to the class. The inheritance. So now we need to adopt some of the components or all of the components of certain class, parent class to a child class, or superclass to a subclass. Now we're going to create the subclass. Same way SE24. We create the subclass, class name, then we click on create. Type is class. Same steps. We selected public access by all. Via all here, we untick final indicator. Click on save. Select the package and the transport request. Then we select from the menu bar the code. Here the code is written as we saw before. But here, as you see, the code will be written in this way. Class, definition public, inheriting from the parent class. This means all of the public section, previous class will be adopted. So for example, we do not need to redefine the variables which were defined before. We do not need to redefine the methods. They will be accessible through this class, the child class, as long as they are public. The protected section will be visible for all methods and inheriting classes within this class. Private is only visible to all methods of the class, but will not be visible for the inheriting classes. Then we save and activate. Encapsulation, as we have just mentioned, we have three types: public, private, and protected. The attribute which is public will be accessible by all methods, all inheriting classes, all other classes, and subclasses within inheritance. Private, defined in private section, and can be accessed only by the classes and not by other classes. Can be accessed only by the class and not by any other class, so not by the subclass, for example. Protected can be accessed by only the superclass and subclasses. So for protected section, the contents will be accessed by the inheriting classes as well, and the other methods within the superclass. The usage of these concepts will be more clear, more articulated within the big example. Now let's just try to absorb the concept and how we create it in SAP. Here in SA24, when we create, for example, a method, here we can define what is the visibility of it, public, private, or protected. The source code, we see the three sections: public, protected, and private. Runtime polymorphism, this is the type which is available in SAP. So we can create classes, different classes. However, the methods within these classes are having the same name. So this method name, for example, let's select single count method, and in any other class we can reuse it. At the same time, in the subclass here, we are inheriting from parent class or superclass to a subclass or a child class. Here we define method, whatever redefinition. So the inherited method, here this is dynamic polymorphism. So same method name, but we are defining it with different functionality, different content. So if I call it through the sub class or the child method, we are calling this piece of code. If we are calling it through the parent class, then it's different piece of code. So the specifier or the parent, calling the parent, and the class with reference to the parent will differentiate which piece of code we are executing. Multiple inheritance. So we have two two classes, and we are inheriting from both of them the components to sub class. So here we are creating subclass ZVAT intelligence, for example, and the source code, as we saw before, we are inheriting from one of them, one of the parent classes, and the multiple inheritance here from the other superclass comes through defining the methods, importing from that in that class with reference to the other class. So inherited from this one, it's selecting asterisk, and from that selecting asterisk plus definition public, inheriting from this one, create public. And then in the method definition, we called methods, importing to what we defined here, single count m, type reference to the select single count, which is a different class. Here to this method, as if we are calling the class or creating object of the class, we pass the inputs, we call the method, and then return to return the output, then end the method. During the second part of this experience, we are going to build the competences within an end-to-end real example, which is a real experience of a sprint. We are going to gain competences of building object-oriented ABAP code and dynamic object-oriented ABAP, supporting the safe Scrum-Agile methodology and approach according to the ITIL, the 7 guiding principles for resilient organizations and solutions. Till part 2. Hasta la vista.